Hello class, we are on page 493, problem number 2, and the problem reads as follows. An ideal transformer has 50 turns in its primary and 250 turns in its secondary. 12 volts AC is connected to the primary. Find. Now, before we find it, let's just go ahead and draw the picture. Okay, ideal transformer, that's 50 turns. So let's just go ahead and draw that. Let's say that that's 50 turns. Okay. And it has 250 turns to the secondary. What's going on?
I still don't know why you can't see those classes.
So we have ourselves a transformer, an ideal transformer that has 50 turns in its primary. And now this is just the primary, so let's call our red coil the primary coil. And let's go ahead and draw ourselves another coil. Let's put a lot of little coils in there, because this should be 100. No, it should be 250. So let's draw a whole bunch of them. Let's call this our secondary coil. Now I want to make sure that you understand that it's the green one that's the secondary, and it's the red one that's the primary. So even though I have my arrow pointing this direction, I'm really pointing towards the red coil. Okay, so let's look at it. It says 12 volts AC is connected to the primary. So if we have 12 volts AC connected to the primary, and our red coil is the primary. Go ahead and draw ourselves this. So this is our volts AC. It's 12. We want to know how many volts AC is available at the secondary. So let's go ahead and complete our drawing here. So what is our voltage AC here? You know that we have ourselves another monitor or voltmeter. So this is our voltmeter. Now what are we going to use? We're going to use our trusted formula, and that's voltage at the primary. Let me turn this around. We have voltage at the primary over the number of turns at the primary. Is equal to the voltage at the secondary divided by the number of turns in the secondary. So how many turns do we have in the secondary? 100 turns. How many turns? You know that's wrong again. I'm stuck on that 100. It's actually 250 turns. How many turns do we have in the primary? Let me read it real quick. 50 turns. So we know two things. We know our primary turns. We know our secondary turns. Now, what is the voltage in the primary? We even know our voltage in the primary. So what are we looking for? We're looking for the voltage that's produced in the secondary coil. In fact, the voltage AC that's produced in the secondary coil. So all we're going to do is do a little bit of manipulation here. We're going to find that voltage in the secondary AC very quickly. So we have NS divided by NP times VP is equal to VS. That equals to, since our NS is 250 turns, and our NP is just 50 turns. We're going to multiply that times our voltage in the primary coil, which is just 12 volts AC. So we can already see that 50 goes into 250 how many times? It's going to go into it 5 times, and 5 times 12 volts AC is just going to be 60 volts AC will be produced in our secondary coil. So let's go ahead and write that. The volts in our secondary coil is 5 times 12 volts AC, which is just equal to 60 volts AC. Let's see what else they're asking, if they're asking anything else. Okay, it says the current in a 10 ohm device connected to the secondary. So let's take out this voltmeter. And let's put a resistor, call it R, and it's 10 ohms. So now we want to know what the current is going to be in this resistor. Okay, so how do we find that? Well, we're going to use Ohm's law. Da, 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 da. So Ohm's law states that the voltage is equal to the current times the resistance. Okay? Do we know our voltage? Yes, we do. Our voltage is just Vs, which happens to be 60 volts AC. So we know our voltage. Do we know our resistance? Yes, we do. So we can just manipulate Ohm's law, the relationship voltage is equal to current times resistance, and find the current in that resistor. So let's do that. But let's do it on a different page. Well, I'll do it down here. Voltage divided by resistance is equal to current. So our voltage is 60 volts. Let's say AC divided by the resistance, which is 10 ohms. So our current is 6 amps. A volt over an ohm is just an amp. This is our current. All right. Now, oh, you're fine. Now, we have one last part. The last part says, what is the power supplied to the primary coil? Okay. Now we can find power because we have ourselves another relationship, and that relationship is as follows. Power is equal to current times voltage. But there's something else that you should know. Even though we have that, I want you to know that the power in the secondary is equal to the power in the primary. The reason is this. Energy in the secondary over time is equal to energy in the primary over time. Now we can multiply both of these sides by time. Time over time is defined as 1. Time over time is defined as 1. So what do we end up with? Energy in the secondary is equal to energy in the primary. What does this look like? It's the conservation of energy. Basically, you will not break this law, the conservation of energy. Conservation of energy, again, states that energy can neither be created nor destroyed. It's only transformed. So, because we know that, if we can find our power in our secondary, then we know what the power is in the primary. Let me ask you a quick question. Do we know the current in the secondary? Do we know the voltage in the secondary? Let's go back and see. We do have our voltage in the secondary. We know what that is. It's 60 volts AC. And we know what our current is. It's 6 amps. So 60 times 60 volts times 6 amps, it's going to be 360 watts. So we know our power in our secondary. Power in the secondary is equal to current in the secondary is equal to voltage in the secondary. Current in the secondary is 6 amps. Power in the secondary is 60 volts AC. So that means that power in the secondary voltage in the secondary. So that means power in the secondary, 6 amps times voltage in the secondary, 60 volts AC, is just equal to 360 watts. Okay? And because the power in the secondary is equal to 60 watts, and power in the secondary is equal to power in the primary, because because of the conservation of energy. Power in the primary is as well equal to 360 watts. Chad, how you doing?